Trane Controllers through the ages.
Trane began in the era of electromechanical control, where units were driven by relay logic, contactors, and thermostats. This was the foundation of HVAC, but it lacked the intelligence, communication, and ability to meet the growing demand for automated control and energy conservation that electromechanical controls could not provide. In the 1980s, Trane's first step into digital central control and building automation came with the Tracer 100. For its time, the Tracer 100 was a breakthrough, allowing operators to schedule equipment, monitor performance, and acknowledge alarms. But it had clear limitations. There were no graphics, only text screens, and later versions offered a very limited ASCII-style visual. Functional and forward-thinking, yes, but still far from the integrated graphical systems that would follow. If you connected through a PC, the operator ran software on MS-DOS, or Microsoft Disk Operating System, the text-based platform that predated Windows. At the controller itself, technicians could plug directly into the controller's terminal port and view status or make adjustments through a simple text interface generated by the board's own firmware. Trane's introduction into full unit direct digital control, or DDC, began with the TIM, or Tracer Integration Module. The TIM directly controlled Trane units through a structured set of inputs and outputs. It was installed in what we called the mid-range units, and the choo-choo Trane, which are the pre-IntelliPACs. It featured supply fan control, compressor staging, failure alarms, temperature inputs, and airflow verification. The TIM allowed the Tracer 100 to issue discrete commands and get real-time feedback from units using a defined input-output map that included points like compressor on-off, heat fail, dirty filter, supply air temp, zone temperature, and airflow. It was a foundational step in Trane's move towards centralized programmable control. Then came the TIME, or Tracer Interface Module Enhanced, which emulated thermostat logic to integrate third-party equipment into the Tracer 100 on the standard thermostat terminals, R, G, Y1, W1, etc. Alongside the TIM, Trane developed the PCM, or Programmable Control Module, which was used for air handlers, climate changers, and generic input-output control. The PCM allowed the end user to create custom programs to control almost anything, and could be configured for a wide range of applications, making it a versatile tool in the early days of building automation. Together, the TIM and PCM represented Trane's first real push into distributed digital unitary control. The next series of units introduced were the smaller Precedent and Voyager units. These units split up unit control and communication into two different circuit boards. You had the Unitary Control Processor, or UCP board. The UCP was the brains of the unit, and can communicate out in two different ways, each requiring its own module. If you wanted to tie into the building automation system, you needed the TCI, or Tracer Communication Interface. If you wanted to use a conventional thermostat, you needed the CTI, or Conventional Thermostat Interface. These Voyager and Precedent units were the first Trane units to have the main supervisory control board connected to other application-specific